Hello everyone, welcome to Dakshana e-classroom program. So I hope everyone tried their best in FST 21 paper. Let's discuss the solution of paper 1 for part physics. So the first question is a nuclear reaction is given. A radioactive nucleus A at rest disintegrate into two nuclei B and C. The masses. So here the question given is that here this is question number first. So A is disintegrating into B plus C, and the masses, this is 12m and this is 4m. Masses for B and C is given to you. So 12m and C is 4m. The Q value of the reaction is also given. So Q value is given as h square divided by 24m lambda square. The energy liberated in reaction is completely imparted to the product B and C as kinetic energy. So it means this is the kinetic energy liberated in the reaction, and where this energy is liberated and in which form, that is in the kinetic energy. This is the kinetic energy of B and C. So that is the information provided to us, and it is also mentioned that this is at rest initially and disintegrating into B and C. So definitely by conservation of mass I can write it will be roughly equal to 60 m, and plus because this energy will be liberated by rest mass, is it? So some mass defects, the decrease in mass will be converted into energy. So that will be also there. So let's talk about the options. So here a de Broglie wavelength. So means for de Broglie wavelength we need the speed of basically B and C. So first thing is B and C, I can say this is B and this is C. So by let's say its velocity is V and its velocity is some U, then by conservation of linear momentum I can write 12 mu must be equal to 4 mv, and this implies V must be equal to 4u. So one relation we got this. Another is kinetic energy. I mean conservation. This much energy is released in the form of kinetic energy of B and C. So another relation that you get is 1 by 2 into 12m into u square plus 1 by 2 into 4m into v square, and this comes out to be h square divided by 24 m and lambda square. So we got basically this, and from here we can get u and v. So I can substitute here v is equal to 4u, then I will be getting this is 6m u square plus this is 2m into v square, and v if I am substituting it here, so it will be 60 m 60 u square equal to h square divided by 2, it's like this, 24 m lambda square. Then further we can simplify, it's 32 32 plus 6, so that will be equal to 38. Okay, little bit small calculation error. So it will be basically, I'm cancelling it's 3u and substituting it here, it will be 9, and 18 plus 9 into 2, 18 plus 6, so it will be 24 m u square is equal to h square divided by 24 m lambda square. Solving it, u I'm getting basically h divided by 24 m lambda. So we got basically u, and v will be equal to what? V is 3 times of u, so that will be equal to h divided by, this is 8 m lambda. So we got actually velocity of both B and C. Velocity, then I can get momentum. So PV is equal to what? It's mass multiplied by U. So that will be coming out to be h by 2 lambda. This is PV. Then de Broglie wavelength it's talking about. So momentum of A will be equal to what? I can substitute this is velocity multiplied by mass. So that will be coming up. This is not A, this is C basically. So that I am getting 4 multiplied by this, so it's h by 2 lambda. So we got momentum of B and C. Okay. Now next is lambda. So we know lambda de Broglie is equal to h by P. So lambda A is equal to what? H divided by PA, and that is equal to h divided by PA is what? Sorry, we are asked B and C. So this is B, and so if I am substituting here PV, then it will be h into 2 lambda, and just gets cancelled, so it's coming out to be 2 lambda. Similarly, lambda c will be equal to h divided by pc, and that is h divided by same pc, that is h multiplied by 2 lambda, and we are getting 2 lambda. So here the de Broglie wavelength of D is 2 lambda, that is also correct option. The de Broglie wavelength of C is 2 lambda, that is also right option. So B and C, like option A, option B, both are correct. Let's talk about C. Okay. So first thing is, this is the energy released. If I just look at it from mass of this and plus the mass that is converted into this energy will be equal to the mass of A. So I can write mass of A is equal to basically 16 plus this is equal to how much? I can write this is equal to m or some delta m into c square. So delta m is equal to divided by c square. So that mass will be added. So it's h square divided by 24 m c square into lambda square. This will be the mass of element A actually. So with that, like your C option also matches correct. This is de Broglie wavelength of C that we have already calculated, that is coming out to be 2 lambda. So means C is D is not correct. So for question number 1, the answer is A, B and C. Let's see next question number 2. Okay, next question number 2. So H plus, He plus and O plus plus all starting from rest are accelerated through equal electric potential. So all are accelerated through, this is potential, accelerating potential. And equal accelerating potential, all accelerated. And pass through a region in which there is a uniform magnetic field. Let's say the magnetic field is B. So the region is having B is the magnetic field, and perpendicular to their velocity. The masses of this is also given. If I am taking this is m, this is 4m, and this is 16m. Masses are given, and according to this, I can write charges. If I am taking this charge is q, then it is also q, and it is basically 2q. So that is the charge also given. Then we know actually, because this is the accelerating potential, so the kinetic energy that they will be gaining is V multiplied by charge. So kinetic energy will be, this is QV, and this is 2Q multiplied by CV. So these are the kinetic energy of these particles. And then we are supposed to compare about them. Okay, so these particles, we know when they are entering a perpendicular magnetic field, they actually revolve in a circle, is it? So the radius of that circle, we know the formula. If there is a uniform magnetic field, is it? One particle is entering with velocity, mass, m, charge, then R is given by mv by q, right? This is, or we write it basically P by QB, or we write it actually under 2km by QB, is it? And K is written in terms of QB. So if I am substituting it here, let's say charge. Okay, so now let me write first expression in terms of this for the radius, then we will compare it actually. So R coming out to be, let me write it first for this, then I will change the remaining things actually. So here what is that? It is coming out to be under root, this is R is 2, this is 2, K is equal to what? Q into V into this is M. M is M divided by Q into V. And it can be expressed in 1 by V, or this is 1 by, this is 2 potential mass divided by under root R. This is Q and Q, so it's under root Q into V square. So this is the expression I am getting actually for radius. Now let's write the radius for H plus, He plus and O plus plus. So RH plus is coming out to be under root, this is 2 Vm divided by QB square. RHE plus, that will be equal to under root 2. V is V, M is 4M divided by Q. Q is how much? Q is also Q, and B square is B square, so it's coming out to be, if I am taking this is, let's say R naught, then this comes out to be 2R naught, right? Simplifying. Similarly, RO plus plus will be under root 2. Here B is V, M is 16M divided by Q is 2Q, and B is B square. Simplifying it, we are getting basically this is 8, so it's 2 root 2 into R naught. So these are the radius we are getting. Let's now look at the answers. So H plus will have least radius among all these three particles. H plus will have least radius, means that is correct option A. O plus plus will have largest radius, so that is also correct among all these three. He plus and O plus plus will have same radius, definitely not. All will have same radius, no, that is not. Means A and B both are correct options. So this is about problem number 2. Okay, next question number 3. So which of the following statement is correct? We need to check for that. If the energy of bombarding electron in coolest tube is increased. So first you need to understand what is coolest tube, where it is used. So basically it is talking about the generation or production of X-rays. There we use coolest tube. So if the energy of bombarding electron in the coolest tube is increased, then the cutoff wavelength decreases while the characteristic wavelength remains unaltered. So here you must understand what is cutoff wavelength and what is actually characteristic. So characteristic wavelength depends on the material of target whichever we are using. When we are changing the material, only then it will be changing. So that will remain constant. And the accelerating voltage basically increases the kinetic energy of electron, and that result in basically like the decrease in minimum or cutoff wavelength. So that means if the energy of bombarding electron in the coolest tube is increased, then the cutoff wavelength will decrease while the characteristic wavelength remain unaltered. So that means it is correct statement. If the energy of bombarding electron in the coolest tube is increased, then the cutoff wavelength, no, that's not correct, will not increase. The characteristic wavelength is characteristic of target metal, while the cutoff wavelength is a function of energy of bombarding electron. That's absolutely correct. So C is also right. The characteristic wavelength of is the function of energy. That's definitely not right. So here it's simple, straightforward question. Question number 3. So here your A and C both are correct options. Let's talk about problem number 4. Water of density rho in a clean square aquarium form a meniscus on vertical wall as shown. You need to understand here actually this is the wall, and this is actually filled like this, and here it's forming almost 0 degree angle. So this is the situation, and here it's like a point. This is mentioned as A and B somewhere here. See, it's not given, but hopefully it will be here actually. It should be provided to you actually. So this is height is given as H and some pressure here P0, atmosphere pressure. This is all meniscus on vertical wall as shown in the figure. From the contact angle between the water and the solid wall is 0 degrees. So angle of contact is given as angle of contact, that is also given as 0 degree. Surface tension of the water surface tension is given as S. This is surface tension. And let's talk about now actually. So pressure at point B just below the point of contact A is equal to P0. So here actually it's talking about, this is a contact point and it's saying just below the point A the pressure will be P0. The answer will be definitely no, because we know actually whenever there is curved surface on this side, the pressure is actually what? It's lower, right? So pressure at this point and this point, it will, because outside, if this is the point, this is a point here, then outside it's P0. So definitely inside this side liquid surface, inside the liquid, the pressure will not be P0. So A cannot be right. The radius of curvature of meniscus at point of contact, this we can write actually. So here you must be understanding, first thing is this is a like wall and the surface is like this, so it's like a part of cylinder actually, and we must know the formula of pressure or like difference, is it, or excess and pressure in case of cylindrical surface. So here the excess pressure, first thing is here pressure is P0, then here pressure must be P0, and this height is rho gh. So I can write here the pressure will be P0 minus rho gh. So PB I can write is equal to P0 minus rho gh, P0 minus rho gh, is it? And this is basically the, because here pressure is P0, is it, and as I am going the pressure decreases actually, because whatever the pressure is PB, I will be writing PB plus rho gh will be equal to pressure at this point, and that should be equal to P0. So P0, so from there I am getting this pressure actually. So we got pressure at point B is coming out to be this. So here on this curved side, the pressure will be axis, and the difference in pressure, so I can write delta P is equal to how much? Rho G H, and this should be equal to surface tension divided by its radius of curvature, let's say R, for cylindrical surface, single cylindrical, sort of like you can say cylindrical solid cylinder. Basically this is the axis pressure, so from there I am getting radius of curvature is S divided by rho G H. So yes, this is your correct answer. And pressure at point B just below the point of no A is equal to P naught, not right. Radius of curvature of meniscus at point of contact is S by rho G S, that's correct. Net force applied on portion AC of the wall on the water is towards the wall. So it's talking about the net force. First thing is definitely this wall will apply because of fluid pressure, this water will apply force on the wall this side, so wall will apply on this side, plus some surface tension force will be there, so net force will be towards this actually at some angle. So definitely it's saying it will be towards basically left, and that's not correct answer. I hope you understand. First thing is liquid will push the wall this way, so wall by Newton's third law will push the water in this direction, so some force will be like horizontally right on the water by the wall. Due to surface tension at this point it will try to lift, so some force will be upward, so resultant force will be like one component this way, another component at this point will be lifting upward, so this point this, so it will be somewhere here actually net resultant force. And the option saying net force applied by portion AC of the wall on the water is towards the wall, that's definitely not correct. Radius of curvature of meniscus is minimum at the point of contact. Now it is saying at this point radius of curvature is minimum. Here this is correct answer actually. You can see it's not the capillary. In case of capillary basically it's almost like many times we take it almost like a spherical shape. In a spherical shape we take the radius of curvature almost same, but here what is happening, it's like a big rectangular tank is there. So here you can see it's what, a plane surface, and in plane surface is there, then what is happening here, radius of curvature, here radius of curvature is infinite. And you can see here as we are moving towards the wall the curvature decreasing, right? So it will be a part of some circle, and it's like becoming more circular. So here by that way directly we can write here the radius of curvature of this meniscus will be least, so that is also the correct option. So now your option will be B and D, right option. So that is about problem number 4. Let's see the next problem number 5. A dumbbell consisting of two equal particles of mass phi. So here problem number 5, a disc is rotating, this is a disc, and one dumbbell is there, mass m, and the separation is given as 2a, and center to this center is given radius r and angular speed omega, right? This is the system. So a dumbbell consisting of two equal particles of mass m connected with massless rod. This rod is massless, mentioned, separated by a distance 2a. It is initially attached along a radial line to a disc that is rotating at angular speed omega radian per second about a vertical axis as shown in figures that we can see directly. The center of the dumbbell is at a distance r from the center of the disc. Choose the correct statement about the motion of the dumbbell after it is suddenly free. So first you need to understand the problem actually here. So this is the system. This disc is rotating in a horizontal plane with constant angular speed omega. On this we have attached a dumbbell which is connected by a massless rod. Each of the mass of this like dumbbell is consisting of two particles, each of mass m, and they are separated by a distance of 2a, and the center of the dumbbell is at a distance of r from the center of the disc. Okay, so this is the information given. Now motion of dumbbell will be pure rotational. It's talking about, so suddenly now it's rotating. Suddenly what we are doing is we are releasing this, so the dumbbell is released. Now first look at it actually. What is happening when it is rotating? It is having some angular speed and it will be like rotating like this. So center of mass will be moving in a circle, and you must be knowing that because whenever something moving in a circle, some centripetal force must be provided and it will have some tangential speed also. So the center of mass will have some tangential speed. and the dumbbell will have some angular speed that you can even, so like it is rotating two particles about this, so it will have some velocity v1, it will have some velocity v2, and that we can, this is r2, this is r1, so r1 into omega, r2 into omega. So even if I look at basically by sitting observing like from one particle, then also it will be like rotating, and that angular speed will be equal to omega. So that is the angular speed of dumbbell. Right, now motion of dumbbell will be pure translational, that is actually like, because it will have, once it is released, it will have some velocity in this direction, and once it is released it will move this way also, and it will be like moving away because centripetal force will not be provided once it is released. So it will not be moving actually, because another thing is velocity this way and one velocity this way, and it has some angular velocity. You can see if you are sitting at this particle, then its velocities are different. So its velocities are different, then it is like having some angular velocity this way also if you are looking at it, because just try to imagine it. Now it's, if I am saying this is, let's say, ball A and this is ball B, right? Now what is happening, let me write, this is ball A and this is ball B. So this is in this situation. So if it is not having angular velocity, then it must be, when it is coming here, it must be in same orientation. But once it is rotating from here to there, you can see the orientation of this dumbbell is changing. So that means it also has some angular speed, and by just doing this calculation you can get exactly the angular speed of this dumbbell is also omega, correct? So that is one thing. So definitely once it is released, there will be no external torque on this system of force about this center or center of mass of this dumbbell. So definitely I can say it will, once it is released, it will have some angular speed also. So the motion in that case will definitely not a purely translational motion. So first statement is definitely not right. So motion of dumbbell will be purely translational, definitely not correct. Angular velocity of dumbbell remains same, and that is omega. So first thing is angular velocity, you can just simply check it. I can even calculate it. So see, this distance r1 will be basically capital R minus a. R2 is equal to what? Capital R plus A, and V1 is equal to R minus A into omega. V2 is equal to R plus A into omega, and we must be knowing, if on a rigid body we know the velocity of 2 points, then the angular velocity of that velocity body can be calculated. So that comes out to be basically V1 minus V2, or you can write V2 minus V1 into separation, that is 2A, is equal to what? This relative velocity is equal to separation multiplied by angular speed. Let me write it omega prime. Okay, and I can substitute here. So V2 minus V1, how much I will be getting? R omega getting cancelled, and this is A omega and A omega. So this is 2A omega is equal to 2A into omega prime, and you can check we are getting exactly omega prime is coming out to be omega. So that means the angular speed of rotation of this dumbbell about its axis is omega, and omega will change when some external torque or some force will be acting on this body, and that is not acting, is it? Once it is released, there is no other force acting, so definitely this will remain constant. So then the angular velocity of dumbbell remains same. That's correct option B is right. Next, kinetic energy of dumbbell will be given by, so let's first calculate kinetic energy, then we will talk about it, we will say how much it is. So kinetic energy can be calculated because before release I can calculate kinetic energy, and after release no change in kinetic energy is coming because no work, nothing is done. So definitely in that way I can say even after the release kinetic energy will remain constant. So I can calculate the kinetic energy before. Okay, so kinetic energy means I of this about this axis multiplied by omega square. So I can be written as half into m into r, that is r minus a, mr square into omega square, plus half m into r plus a whole square into omega square. This is the kinetic energy of dumbbell system. This can be simplified, so 1 by 2 m into omega square. This is r plus a, r square plus a square minus 2ra, and this will be r plus a whole square, so r square plus a square plus 2ra. So plus 2ra minus 2ra I can directly cancel, and it will be 2ra square, 2r square plus 2a square, right? this 2 can be taken out, then it's getting m omega square r square plus a square. So this is the kinetic energy of dumbbell system. So in C option it is saying the kinetic energy of dumbbell will be given by m r square omega square. That's definitely not right. The kinetic energy, it matches with option D. So I hope you understood. First thing is, this is the D is the correct option. Another thing is, you can imagine if it is in this situation, then after it is rotating, it's changing its orientation, right? Here this is the orientation, then once it is rotating, it's so that is possible when it is also rotating about its own axis. So it also has, in this system, it also has angular velocity, and calculating here we are getting it's also coming out to be omega. And because once it is released, there is no torque, nothing is acting on this system, then why omega will change? Understanding? Because you know, if a particle, even if in like purely translational, if it has velocity v, then it will not change until and unless some external force is acting on it. Exactly same situation for angular system also, angular motion also. So once its angular velocity is omega and after release no force, nothing is acting on it, then why it will change actually? So that is the situation. And here your for problem number 5, your option B and D will be right correct answer. So B and D will be right answer. Let's talk about next problem number 6. Okay, next question number 6. So space capsule is in circular orbit of radius rc about the Earth. So let's consider this is Earth, and its space capsule is in a circular orbit of radius rc. So let's say this is space capsule, right? A short burst from the rocket in the backward direction increases the kinetic energy by 20%. So in this situation, let's say its orbital speed initially v naught, radius rc, then I can write its kinetic energy initially is half mv naught square, and potential energy is equal to minus gmn by r naught, like rc initially, and we know actually this is also equal to gmm by 2rc. So total mechanical energy initially will be minus gmn by 2rc. This is the mechanical energy initial or total energy. That comes this plus this, then we are getting this. Okay, now this is the situation. So now it's given the kinetic energy increases by 20% because of some burst in this rocket. It's increasing the kinetic energy by 20%, means the kinetic energy after burst, is it? It will be like 20% like increase, 1.2 times of kinetic energy initial. So that will be like, we can write 1.2 into gmm divided by rc. That will be the kinetic energy. Now total energy after the burst will be equal to what? So this I can write, because no change is happening in this. This is changing, so I can write it is minus gmm divided by rc plus 1.2 gmm divided by 2rc. 2rc, it will be also 2rc, because this it will change by 20%, so this 1.2 I write. Simplifying it, it will be like how much? 2, then it comes out to be 0.8 gmm divided by 2rc. So that you can see it is basically 0.8 times of, it will be like minus initial mechanical energy, right? So we got first this relation. Now whatever it's saying, so total mechanical energy of capsule decreases, it's actually negative. So you can see in magnitude it's decreasing, means the mechanical energy is actually increasing. So A is not right option. Time period of capsule will increase. We need to understand that. So first thing is, what is happening initially, its velocity is v naught. Its kinetic energy now has become 1.2 times. So I can write kinetic energy final after the burst. Is it? After burst. So let's say kinetic energy is half mv prime square is equal to 1.2 times 1 by 2 m into v naught square, that is equal to 1.2 into half into, I can write it gmm divided by, or simply like write initial v naught. this comes out to be simply gone. All this is d prime is equal to under root 6 by 5 v naught. So remember, it's exactly at this point the velocity has increased because of thrust. So what will happen? It will try to escape from this circular orbit, and because of that, you must be remembering the things that how actually the orbit of satellite or even like orbits of planets around the sun is elliptical. So here, if the velocity is v naught, then it will be circular orbit. But here, what is happening? Immediately or like instantly, the velocity has increased by like this root 6 by 5 times v naught, but position is still same. So this will be like what? Parisi, and the particle will move in its like elliptical orbit like this. Is it so? That will be like this will be like mg, and this is the Parisi, and this is the information exactly given. So let me write here the radius is RA and here the velocity is VA. Then I can use conservation of energy and conservation of angular momentum conservation. Then I will get the relation for this and this actually. So compared to this point after burst, is it? So conservation or mechanical energy conservation, then it will be like half m. This is half m v prime square minus g m m divided by rc initial. Finally, it is half m v a square minus g m m divided by r a. It's about this point. So conservation of mechanical energy conservation between this point and this point. Then I will get this relation. Actually, here v prime I am already having in terms of v naught. VA and RA are two unknowns. We need one more. So that is angular momentum conservation. Then with that I will get m v prime into RC should be equal to m VA into RA. So these are actually two relations. RA, we can write 1 and 2. Simplifying these two, we can get exactly RA and VA. So solving this basically, I am not going to solve it. It will take time. You can go through it. We will get actually RA is coming out to 1.5 times of RC. So here, first thing is orbit become elliptical, and you must be knowing in case of elliptical orbit, the time period of planet depends on what? Semi-major axis. Clear? And now semi-major axis, now it will be what? It will be like, you can say semi-major axis has increased. This is RC and this is 1.5 RC, so it will be like semi-major axis. Semi-major axis. That will be RC plus 1.5 RC divided by 2. This is R semi-major axis. You can see it has increased. So definitely time period T square is directly proportional to R semi-major square. So what will happen to time period? Definitely that will also increase. Clear? So now we are in position to answer all the question. Total mechanical energy of capsule decreases. It's definitely not right. Time period of capsule will decrease. Also not right because semi-major axis. Distance of FG from the center of Earth is 1.5 RC. That by solving these two equations, we are actually getting RA is equal to 1.5 RC. So that is the distance of FG point from center of Earth. So that's correct option C. And the mechanical energy of the event short burst is E1. The final mechanical energy after the event is EF. So that we have already calculated. So here mechanical energy is initial. Mechanical energy here we are getting initially this. After short burst we are getting this. So that is basically 0.8 times of initial mechanical energy. So for question number 6 we are getting actually C and D we are getting right answer. Right, let's see next problem. Okay, next question number 7. Let's read it first. So here it's mentioned the pitch of screw gauge is mentioned as 0.5 mm pitch, and there are 50 division on circular scale. 50 division on circular scale. When there is nothing between the two studs of the screw gauge, 46th division of the circular scale is coinciding with the reference line, and 0 of main scale is not visible. So this is important point actually. Here you must understand, when 0 of screw gauge is visible, that means actually like normally like it comes exactly at some point, and not like 0 exactly getting in between, like is it? So here what is happening, 0 is not visible means like it's covering more. So basically it's giving you what, like already it's giving some less reading, so it will be like coming at exactly point. You need to rotate, by the time some reading will be there, some gap will be there. So you need to understand that basically here the error will be what, it will be like negative error, and it should be added in the final value actually. We call that zero correction. So that is the situation here. 46th division of circular scale is coinciding with the reference line, and 0 of the main scale is not visible. When the wire is placed between the studs, the linear scale reads 2 division, and 20th division of the circular scale coincide with the reference line. The correct statement is, so 50th division, 50 division. So we can write this pitch is equal to what? Pitch 0.5 is equal to least count into 50 division. Right, so this implies least count is coming out to 0.01 mm. That is also asked, so A is correct option, least count. Then here B, zero correction, that is equal to least count multiplied by this here, like you can understand if you are like gone through the screw gauge, how it is working and how we measure it. So from there I can directly write it. This will be like multiplied by not 46 division, it will be like 4 division. Is it 50 minus 46? That will be like 0.01 multiplied by 4, and that is equal to 0.04 mm is the least count, like zero correction. So zero correction is 0.04, and for the reading, so this is also correct. Reading, is it? So here 50 divisions are mentioned, and it's not mentioned even that like on main scale how much exactly one division equal to, but like from there we can write actually it's normally like in 50 division, like the main scale reading will be, this is the smallest basically main scale reading. So by taking that, I can have the reading will be 2 into main scale, that is 0.5 plus 20th division, so 20 multiplied by least count 0.01, and this zero correction must be added here, so plus 0.04. So the reading will come out to be, this is 1.24 mm, and this option actually not matches with, so radius is 0.65 mm, that's not correct answer. All of these, that is also wrong, so A and B are right option. So that is your problem number 7. Let's see next, like 8, 9, 10, it's based on some paragraph. So here it's given, in general YDSC setup, a light of wavelength 600 mm. So this is a paragraph based question, and YDSC here is the main part. So lambda used is 600 nanometer in case of YDSC. Used D represent the distance between the two slits, small d and capital D, that normal standard general process, and Y represent the distance of the fringe from the central maxima. Now we are supposed to, which of the following correspond to the maxima. So in this situation actually like different possibilities are given. Here let's say this is a small d and this is given as capital D, and if I'm talking about some general point at a distance y, then we should know what is the condition of like maxima and minima. So here it comes actually the path difference delta x is equal to d sine theta is should be equal to n lambda for the case of maxima, and delta x is equal to d sine theta should be equal to 2n plus minus 1 into lambda by 2 plus 1, I am taking n from 0. So that is a condition actually, and sine theta for small value I can write y by d, so it's d y by capital D is equal to n lambda, y I am getting n lambda into capital D by small d. So what you need to do is that actually this is the condition for minima. Now you need to check by substituting like first A, B, C, D. So this is the like you need to check actually. There is no shortcut option for this. So you need to substitute like for A, third condition means small d is equal to 2 mm, and second then capital D is equal to 1.5 meter, and P y is equal to 1 meter. So you need to gauge whether you are getting some integer value of n. If you are getting integer value of n, then it will be like yes maxima actually, because we are applying here the condition of maxima. So that you get actually like for 8th question, just simplifying, you will getting like for D, and it will match exactly. Similarly, for question number 9 and 10th, okay, small fraction actually. This is the condition for maxima, you must be understanding. This is the minimum. Now, just checking it because different possibilities are given in question number 8. So, you need to check for every option actually. In checking, then you will get actually for D, it satisfies exactly, correct? Similarly, for 9 question, it's asking about which of the following corresponding to minima. So, for that, you what D is given, capital D is given, different values of Y is given, and lambda is constant. So you need to check whether like it's satisfying. Now in 9th option, 9th question, it is talking about minima. So you need to write here dy by capital D is equal to 2n plus 1 into lambda by 2. So you need to check y is equal to 2n plus 1 into lambda into capital D by small d. And now you need to verify it actually that for different options given here which is exactly matching. So according to that, you will get actually in case of 9, your C condition exactly satisfied. Similarly, question number 10. So here 10 is particularly talking about 5th maxima. So that means you need to write small d into y divided by capital D should be equal to 5 lambda for 5th maxima. Then you will to again check for the available options. So here you get A option matches correctly, because lambda is time consuming, small calculation part is there, so you do it by yourself. There is nothing, no other option. Luckily you may be getting it. Okay, next question number 11, 12, 13, that is actually based on a paragraph. So two capacitors C1 and C2 are connected with battery and resistance as shown, and C1 is initially uncharged in C2 and charge on both plates of C2 is Q1. Switch S is, so this is system is given, let me tell you exactly. So one capacitor this C1, another C2, and C1, C2 connected with battery EMF E, resistance 2R, and this switch. This is the system given. Initially switch is open and the plates have charge both Q1 and Q2. First you need to understand what is the meaning of this and how this charge will be staying actually. So this you can consider just like this, two plates are given and charge is Q1 and Q2. So we know actually in that case charge on this surface is given by Q1 plus Q2 by 2, and if both are same then I can write, if this is also Q1 then this will be also Q1, this will be like Q1 on this charge. So that means charge here will be 0, 0, and here also it will be Q1. So this is the distribution of charge on this system, right? So that is so means inside the plate there is no charge, and you must be remembering actually that on a capacitor the charge which is actually lying on the surface is considered as charge on capacitor, means that is used for storing energy, not this outside charge. Okay, so this is the system now, and like what will happen actually here, battery EMF E, and it's mentioned actually in the problem C1 is equal to C2 is equal to, so C1 equal to C2 is equal to C. Initially this is the situation. When I am switching it on, then what will happen, these two capacitors in series, so C equivalent I can write it is equal to what, C by 2. So the circuit will become effectively, if I talk, then inside the plates like inside surface there is no charge, so the system will behave like this actually, EMF E, resistance, and this, and C by 2, 2R, E, and circuit. So in this situation Q, charge supplied by this, and that will be like equal because two capacitors are connected in series. So this will be like C equivalent into E, 1 minus E raised to power minus T by tau, and tau is equal to R equivalent into C equivalent. So this is the system. So now once we have charge Q, then in that situation here will be charge Q and here will be minus Q. I mean, let me write it, draw it a little bit larger. So here it will be plus q, here it will be minus q, and on this plate q1 is there, so here it will be again plus q and here it will be minus q. So you can say the left plate will have total charge q1 plus q, right? So that will be the total charge, and if that is the situation, the force between the plates can be written as basically q1 plus q into q1 means minus q divided by 2a epsilon naught. I mean, like basically q by a epsilon naught is the field, but because of only one plate, then q1 by q1 total q divided by 2a epsilon naught is the force, like electric field multiplied by charge on other plate, that is q1 minus q, that will be whole divided by this 2a epsilon naught. So this will be like q1 square minus q square divided by 2a epsilon naught will be the force between the plates, and energy stored can be written as basically that will be only because of this supplied charge. So q square by 2c will be the contribution of energy stored on the capacitor or between the plates of the capacitor. Okay, and here this is the force. If I can divide by d, multiplied by d, then a epsilon naught by d can be written as c. So this can be rearranged as q1 square minus q square divided by 2c into d. Both expressions are correct. So this is the force. If I know q1 already like given, energy stored between the capacitor, and what else it is asking about, energy stored and charge, and like charge expression is given by this. This is the charge supplied by the battery once switch is on, and total charge on this plate actually that is asked. This is q that here it is talking about. That will be q1 plus q charge supplied. Let's talk about the like problem, that is 11, 12 and 13. So here question number 11, it's mentioned initially q1 is 0, it's straightforward 0. Then at time t equal to RC ln 2. So let's first calculate what is the charge. So first thing is, here the circuit system at q1 is 0, so both are initially not like uncharged. Then C equivalent is equal to C by 2, and this is 2, so tau will be like can be written as simply RC, 2R multiplied by C by 2, that will be RC. So then at this time I can write Q is equal to C equivalent C by E by 2, 1 minus e raised to power minus t by, and t is how much, RC ln 2 whole divided by tau is also RC, this. So we are getting actually Q is coming out to be CE by 4, C by 2, and this will be 1 by 2, so CE by 4. So here the charge, that will be like third option. This is question number 11. So here charge is matching with the, in column 1 we are given with energy stored on the capacitor plates of like C2, Q coulomb, like column 2 Q charge is the basically charge on the left plate of this capacitor C2, and F is the force between. So I got small q. This q1 is already given 0. So now what is the energy stored? Energy stored, we can substitute it here, then we will be getting actually energy stored U is equal to, so substituting 16 to 32, and C square E square 1 C will be cancelled, C E square divided by 32, and that's all. So C E square by 32, that will be like second option. It's matching with second, it's matching with column 2, it's matching with third. And force between the plates, so force here it's 0 and Q square by 2 CD, so this is again, so that will be like C E square divided by 32D, and which is matching with option like S. So here second, third and S, so here we are getting actually 11, it's D option. Exactly same manner we need to check for 12 question also. So I hope you are understanding this part, what is exactly happening. Let me raise, then I will talk about next question number, that is 12 here. So question number 12, it's saying Q1 is given as, here Q1 is CE divided by 4, and time T is given as RC ln 2. So let me first get what is Q, charge supplied by the battery. So that is C equivalent again, CE by 2, 1 minus e raised to power minus this is RC ln 2 divided by RC. So that will be, we will be getting exactly CE by 4. So total charge Q1 plus Q is coming out to be CE by 4 plus CE by 4, that is equal to CE by 2. This is capital Q. That will be matching with the 12th. So charge will be matching with 4th. It's matching with 4th, means column 2, it's 4th option. And now energy stored will be like depending on this. So we were getting earlier also exactly same thing. So here it will be like how much? Say it will come exactly like seconds. U is equal to Q square by 2C, and that will be CE square by 32. That is second part for column 1. In column 3 it's talking about force. So in force, if I like Q1 is also like how much? See here, Q1 is CE by 4, and small q we are getting CE by 4. CE by 4 whole square minus CE by 4 square. How much this quantity will be? Simply 0. So I can write force is coming out to be 0, which is matching with P. So this is second, like 4. This is according to this sequence. Then it will be second, 4th, and P, and that matches with option A. So that is about problem number 12. I hope you understand this part. Similarly, like next question number 13, just small little bit variation. So in this situation, C2 is completely filled with dielectric of dielectric constant 2. Now you need to, so 13 question, C2 now because it's filled with dielectric of dielectric constant 2, so C2 will become basically 2C. Then in this situation, C equivalent will become 2C divided by 3. This is the C equivalent that is changing. So because of that, things will change. And Q1 is also mentioned, this is CE. So, and time constant, it's talking about 8 RC ln 2 divided by 3. So let me first get small q, charge supplied by the battery, and that is coming out to be C equivalent, that is 2C divided by 3 multiplied by E. 1 minus e raised to power tau, T is 8 RC ln 2 divided by 3 divided by R equivalent into C. R equivalent is how much? 2R into C equivalent is 2C multiplied by 3. Solving this, 3 gets cancelled. This is 2. So we will be getting basically 2CE by 3 multiplied by 3 by 4. This is CE by 2. So this is the charge supplied, small q. Total charge will be this charge plus this. So capital Q is coming out to be CE by 2 plus CE, that is 3CE by 2. So which is matching column 2, it's talking about charge, which is matching with which part? So it's matching with second, column 2. Next case, it's talking about energy stored. So energy stored is depending on this, right? So Q square by 2C, then you can get exactly, this will be like how much? That you can get exactly by simply substituting. Third option, it's okay. Just wait, okay. In question number 13 for energy, just need to take care a little bit, because the point is here dielectric has been inserted. So because of that, C has changed, but here it was like just normal C. So we need like C will be replaced by here C2, and C2 will be replaced by 2C. So in that case, energy Q is we are getting this. So this is CE by 2 whole square divided by 2 into C2, and C2 is basically 2C, and solving we are getting this is C square E square divided by 4 into 4, 16 into C, right? And that comes out to be CE square divided by 16. So just take care of that C2 basically, because C has changed in this situation. So we got, this is the charge that is matching with second. In first column it's matching with which option? Like it's CE square, that is third option. And force, so force we can get exactly like from there actually. So force again we need to change here C also, then substituting here force we are getting actually Q1 is CE. So this is C square E square minus this is C square E square divided by 4 divided by 2. C is 2C into D. So we are getting 3c square E square divided by 4, and this is C multiplied by D, and multiplied by one more 4, so this is 3c E square divided by 16D, and that should be matching with uh, our option. It should be matching. We are getting one more extra tool. Okay, see here actually, because initially charge is given CE before it's getting connected, switch is on, and slab is inside a dielectric slab. So because of that, the capacitance will be like C prime will be 2C, because the medium K is equal to 2 is filled, and that will result in change in electric fields. So when it is like inserted dielectric slab inserted in isolated capacitor, then we know actually electric field or capacitance changes. So charge will remain same, and because its Q1 is not changing, is it isolated? When total charge some Q is supplied, then we understood this, and E will be in this situation because epsilon naught will be replaced by K epsilon naught. So that will change actually. One more 2 will come here, so by that we will get this expression actually. So here answer should be this CE square by 16, but it's mentioned actually here CE square by like 8D only. So we are getting actually here it's D will be also there, just one this D and one D will be and D. So this should be actually right answer, but it's not matching here actually. So the answer finally we will get actually charge, we are getting this, energy this, energy we solved this, I think energy C2, no, in force we will get actually here D, so that D, yeah, that's right. So this will be your force, this will be your energy, and energy, final charge, and force. So that is our answer for problem number 13. Let's see next problem for next section. Okay, next section and question number 1 here. So let me read first. A vessel contains 6 kg of water at 0 degrees Celsius. 6 kg water at 0 degrees Celsius. It's given, and water equivalent of vessel at 0 degree is 2 kg, and it increases linearly with the temperature such that it becomes 4 kg. So water equivalent of container is changing, and as it is changing, so water equivalent I can express it's equal to 2 plus slope, that is 4 minus 2 by 100 into T. So it's coming out to be 2 by 100 multiplied by T. This is the water equivalent of the container. Temperature of the system is raised from 0 degrees Celsius to 100 degrees Celsius. This is changed in temperature. If Q1 is the energy consumed by water, so I can write, if let's say specific heat of water, because that will cancel out actually, let's say S, otherwise actually we can take 1 calorie also. So this implies Q1 is equal to what? Q1 is ms delta T, heat absorbed by water. So this will be like m is 6, S and delta T is 100. So this is coming out to be 600. S is the heat absorbed by water when temperature changes from 0 to 100 degree. And another point is container, its water equivalent is changing. So we can't get the heat absorbed directly. We need to integrate it here. So heat absorbed Q2 I can write, this is m water equivalent I like for container into specific heat into dt. So this integration, so that will be basically 2 plus 2 by 100 multiplied by T into S multiplied by dt. Integrating is 0 to 100. Solving it, we are getting actually this is 200 T into S plus this will be like 1 by, or I can get 100 because T square, and substituting the limit, this will be Ts 0 to 100, 0 everything will be 0 at 100. We are getting actually this is 200 S, and this is 100 into 100, 100 will get cancelled, so it's 100 S, that comes out to be 300 S. So this is Q2, and in question it's asked simply Q1 by Q2. So Q1 by Q2, it's 600 divided by like this 300. So we will get simply Q1 by Q2 is 600 as divided by 300 as, and that's equal to 2. So answer is Q1 by Q2 is 2. That is question number 1, integer type. So let's see next question number 2. In the circuit shown figure, S1 remains closed for a long time, S2 remains open. So let me first draw the circuit. So here this is the circuit given, and inductor and this battery 1 volt switch S1. This is 2 Henry, 4 ohm, 2 ohm, and battery connected this way, and S2. So initially S1 closed, S2 open, and remain for a long time. What will happen? There will be no current in this circuit, and this will reach in steady state. In steady state, so current here will be flowing this way, and that current I can write, let's say I1 is equal to simply E. This is 1 volt, so 1 by 2, that is 0.5 ampere, right? And next thing it's saying is that now S2 is closed and S1 is open. After that, what is happening? This is open, S1 open, but S2 is closed. And you must remember the property of inductor, it does not allow to change the current immediately. So what will happen when this switch is changed? This is open, this is closed. Now current will flow in this circuit, but it will not let the current to change. So even when the battery of 4 volt is connected, the current will still flow in this direction immediately. Then we can apply KVL for that situation. So by KVL, I can write minus, this is a 2 L di by dt, and this way, so it's minus 4 volt, and I'm going in the direction of current, so it's minus 4 into I naught, because it's talking about immediately, right? So then we are getting, it's asked di by dt, and that too it's talking about magnitude. So minus 2 into di by dt is coming out to be like 4 plus 4 into I naught, we already got, that's coming out to be 0.5. So simply substituting it here, we are getting, this is a 2 plus 2 as 4 plus 2, it's 6, and dividing by, so di by dt I am getting it's minus 3, mod, then it will be simply 3. So that is your answer for question number 2. Let me first erase this part. Okay, next question number 3. So it's saying figure shows one cone of 200 grams suspended by a vertical jet of water from a garden hose. The flow rate is given, flow rate of the water is 0.2 kg per second, and this is a cone basically, whose mass is this, and water jet is striking it, and striking, and this water is flowing out from these holes actually. So the vertical movement is simply stopping completely, and that momentum, change in momentum, is providing the force to balance, to hold this cone in the air. So that is what happening here actually. The water rises 8 meter if unimpeded, means if it is not allowed to strike this cone, then water from here it's rising, so it's given some speed u, and it rises by some height of 8 meters. So by that I can get the initial speed. So if I take small element of mass m, then I know actually kinetic energy will be converted into mg into 8 meter h. So this implies we are getting u square is equal to 16g. 16g, that is the value of u square, initial speed. And now if it is like striking here at height h, then we can get the velocity with which it is striking v. So that we can write v square minus u square is equal to minus 2g into h. So v is coming out to be under root u square minus 2gh, that will be under root u square value is 16g minus 2gh. So this is v, and if it is striking with v and at what rate, this flow rate I'm like 0.2 kg, so then thrust force I can write, this is v into dm by dt. This thrust force must balance the weight of this cone. So this v is, you can write under root 16g minus 8 like 2gh into dm by dt 0.2, and here m is 200 gram, means 0.2 into g, right? So this 0.2 0.2 simply cancelled out. Now we can simplify it, simply squaring it both side. So it's 160 minus 20h is equal to what? 100, G square. G I am taking it 10. So taking it this side, 60 is equal to 20 into h. This implies h is equal to 3 meter. So that is your answer for problem number 3. Next question number 4. Corridor figure shows an overhead view of corridor with a plane mirror M mounted at one end. So it's a simple straightforward problem. Actually, you must be getting it by yourself. So here it's simply a plane mirror is placed here. One thief is moving here. So what will happen actually? Another it's mounted. A burglar B sneak along the corridor directly toward the center of the mirror. If D, this is given 6 meter D, and from here another D, and along this one person is standing. So if D is equal to 60 meter, how far from the mirror will C be seen when the security guard? So here it's in security guard, and here it's the burglar basically moving in front of the mirror. So what will happen actually, like so that this security guard can see this burglar, the rays from this must be reaching here, and that will be like, so that means like by law of reflection these two angles must be same, and this distance is also given to you. This is D and this is D, so that means this angle is 45 degree and this is also 45 degree. That means here also this should be 45, this should be 45, and this should be 45. And if it is 45, and we know how much, like this is D by 2, so that means 3 meter. So when this will be like visible, when it will be also at 45 means tan 45, this must be equal to this. It's not exactly looking, but it must satisfy this condition. So we are getting directly it's 3 meter, and that's the answer. So when this security guard will be able to see this burglar for the first time, when this burglar will be at a distance of 3 meter from this plane mirror. So that's the straightforward answer for question number 4. And then next question number 5. A cylindrical eraser of negligible mass is dragged across a paper at a constant velocity to the right by its pencil. The coefficient of kinetic friction between the eraser and the paper is, so one eraser, cylindrical eraser, it's like this, is being pulled, and according to the language, the coefficient of kinetic friction, so mu between here is 0.6. okay. The pencil pushes down with 5 Newton, means the pencil is applying a force of 5 Newton on this, and it's mentioned in the problem the weight of this or mass of this eraser is taken as negligible. So means there is no normal reaction because of its own weight, right? So whatever the normal reaction is coming, that is because of 5 Newton of force applied by pencil. And then the height of the eraser is 2 centimeter. This is mentioned as 2 centimeter. And its circular area of cross section, this is 4 centimeters square, and its top surface is displaced horizontally 0.6 mm relative to the bottom surface. So because it's pushed by the pencil, so in that way it's getting deformed like this way. So the surface will be like, so this is displaced by 0.6 mm relative to the bottom surface. That means shear strain epsilon can be written as 0.6 mm divided by its height, that is 2 centimeter. So that will be equal to 0.6 into 10 to the power minus 3 divided by 2 into 10 to the power minus 2, and this is 0.1, so this is 0.06 divided by 2, 0.03. This is the shear strain. And weight we already got, like normal reaction, that is 5 Newton. Area of cross section is this. So this shear stress means tau, you can write this is force, shear force divided, you should understand that this is the normal force. The shear force will come because of friction force, is it? So friction force we need to calculate. So friction force is mu times normal reaction 0.6 multiplied by 5, that is equal to 3 Newton, right? That is your friction force, and this will provide shear stress. So we are getting shear stress, tau is friction force divided by area of cross section. So this is 3 divided by 4 into 10 to the power minus 4 Newton per meter square. Now it's talking about If the shear modulus of the eraser is given by x into 10 to the power 5, find the value of 2x. So that's simple, straightforward. We know the shear modulus. What is that? Strain by stress. So shear modulus is coming out to be simply tau divided by epsilon. So 3 by 4, this I am taking upwards, 10 to the power 4, and strain 0.03. Is it? So this comes out to be how much? 20. This cancelled, and this is 100 by 4, so it's 25 into 10 to the power 4, but it's asking in terms of power 5 Pascal. So this you can write 2.5 into 10 to the power 5 Pascal. So this is the shear modulus. So the value of x is coming out to be 2.5, but it's asking the value of 2x. Find the value of 2x. So that means I'm writing it here. 2x value, that means simply like 2.5 multiplied by 2, that will be 5. So that is the answer of answer for here is 5. Last question. So this is all about your paper 1 for FST 21. So thank you so much. That's all.